With the technological advancements we have today, it is absurd how experts have been producing revolutionary scientific breakthroughs. One of the absolute breakthroughs is the James Webb Space Telescope. It captures pieces of evidence in the form of images that take us back in time. Sit back, relax, and stay tuned as we uncover how experts investigated primordial galaxies through the James Webb Space Telescope. The famous principle that controls our world is the speed of light. It travels at a velocity of mind-boggling 300,000 kilometers per second. Despite this being so swift, we still require more time to traverse to other planets in the galaxy. Our own galaxy, the Milky Way galaxy, is estimated to be more than 100,000 light years away. That only means it's roughly about 30 billion kilometers away. This is how astronomers make use of light to answer the hows and the whys of how the universe came about. These various spectrums are utilized by space-based telescopes. The JWST is unique compared to other telescopes as it functions with variations of infrared light. Galaxies continuously release wavelengths such as gamma rays and radio waves on the electromagnetic spectrum. These supply information regarding the mechanics of our solar system. President Joe Biden made an image public via broadcast that depicts an older universe. It's nothing like we have ever seen. June 12th, the next day, NASA followed through by releasing other images to the mass media. These demonstrate how the JWST has the potential to perform as a viable research instrument. Released photos showed the Southern Ring Nebula and the Carina Nebula. The Carina Nebula is 7,600 light-years past the planet Earth. It is known as the enormous nebula with a diameter extending 300 light-years. Images from the telescope presented it as an aggressive star nursery that includes the Eta Carinae, a supergiant star. On the other hand, the Southern Ring Nebula, only 2,000 light-years away from Earth, is a terrestrial nebula composed of revolving cloud, a dead star that emits intolerable hot and mighty ultraviolet radiation. In its center, a white dwarf is located with visible blown-out layers. Despite these celestial beauties, some photos presented by the James Webb Space Telescope are not all magical. Several photographs just depicted dots and lines. Regardless of the production of these photographs, we are able to see beyond our solar system. Prior to the James Webb Telescope usage, the farthest galaxy, measuring about 420 million years after the Big Bang, was discovered in the name of GNZ11. Astronomers mentioned that it has a redshift of 11.6. The word redshift refers to how far the light from a galaxy has been extended by the cosmos. It simply means the higher it is, the further we look into the past. There might be hardships when trying to use the telescope on a bigger scale, mainly because the cosmos are enlarging. What is causing them to enlarge? Well, it is the dark energy. It is presumed to work on the universe persistently, thus the cosmos are actually further than what we believed in. All thanks to the JWST, we can explore more past cosmological distances. Currently, there are galaxies recognized up to a redshift of 20. SMACS J0723's gravitational lens helped Hao Zhengyan, an astronomer who studied at the University of Missouri at Columbia, found about 88 galaxies at a rate of redshift aforementioned. Take note that the estimates of redshift remain unverified. But if these were true, we are looking at galaxies in their pre-Big Bang condition. 4 of the 10 photos were captured by mid-infrared instrument, or the MIRI, and the rest are by the JWST's near-infrared spectrograph, or the NIRSpec. A team of astronomers headed by Callum Donnan, a PhD student of the University of Edinburgh, found 6 galaxies with redshifts of more than 12, and one possible galaxy at a redshift of 16.7, or about 250 million years after the Big Bang. Moreover, Stephen Finkelstein's team discovered a redshift 14.3 galaxy, known as Macy's Galaxy, which is about 218 million years after the Big Bang. This was visible on the Hubble Space Telescope as a massive explosion of star formations must have produced powerful ultraviolet light, just like other potential far-off galaxies. This might be the reason for the ionization of the gas in space. From the team of Donan's computations, it was discovered that a galaxy releases more UV light when more hot young stars are developing there, which accordingly emit abundant UV light for cosmos ionization. Therefore, high redshift means that there are tens of millions of young stars around 20 million years old, instead of billions of old stars in other galaxies. Experts believe that there are more undiscovered galaxies that gave influence to these recently found galaxies due to a large number of high redshift galaxies and UV light. How much more into the past can the JWST telescope observe, and will that detect the earliest galaxies to form? The JWST is continuing its mission and giving us more information about the past and our universe that will probably give us evidence of our existence. This operation is done through the study of the atmosphere of planets outside our solar system, by the absorption of lights from their own star systems. An exoplanet enters our field of view as it passes across the star's face for a moment. Through the absorbed light, chemical traces from the planets are brought with them, giving data for astronomers to analyze in a process wherein the light received is scattered and placed on a spectrum chart to look for signs of familiar substances. This may help experts to recognize signs of life, such as clouds. There are a large number of planets the size of Earth, according to NASA, that orbits a single star just like our Sun. But they are not certain to be habitable. It is challenging to tell whether or not a planet is habitable. This discovery led to a widespread recognition of the TRAPPIST-1 system. Since then, astronomers have been eager to discover more about these closed worlds that may resemble Earth. The TRAPPIST-1 system will be the subject of one of the first study cycles for the JWST. It aims to search for any substance that would indicate life either in the past or present in the TRAPPIST-1 system. It is recently found that land coverage throughout the planet is substantial for a planet's habitability, not just its distance from its star. Models of exoplanets reveal that with more liquid, there is also more rain and clouds. So more land means more heat. This shows that the amount of liquid on any planet greatly affects its climate and temperature. However, it is difficult to determine how much land or water an exoplanet has through the JWST. An exoplanet the size of Earth called Proxima Centauri b with a red dwarf star is being explored by scientists as they are in a habitable zone. However, it doesn't mean that the exoplanet is habitable. One reason being is that it is tidally locked, meaning that one side is always in continuous darkness or nighttime, and the other side will always be facing a star or daytime, just like our moon is tidally locked to Earth, therefore affecting its habitability. If we are able to gather more information about these exoplanets, it would be very interesting. The JWST was not built to look for alien life. However, this would be used not only to find water, but to track down oxygen, carbon dioxide, and methane as well. Furthermore, it is limited to tracking changes in gases and water vapor concentrators in the atmosphere. Even though it will be challenging, as there are billions of kilometers away, this would provide us with significant information for finding the next version of Earth. These atmospheric gases or clouds will provide data to forecast signs of life. We might still need to advance more of our space telescopes since the JWST still has its limitations. Until that time comes, we continue to explore the vastness of space and gather more information for the advancement in the future. Agricultural activities and volcanoes produce methane gases. Unfortunately, non-biological sources produce much of the gases present in cosmic life. Thus, astronomers may yield an erroneous positive for the existence of extraterrestrial viability. To counter this, they must choose a planet of interest and conduct thorough research on its atmospheric and geological activity. This is where the James Webb Space Telescope comes in, as its earliest evidence let us peek through the scientific progress that is bound to come. It all started with a curiosity about the existence of other galaxies besides our own. Now, through the James Webb Space Telescope, we are able to discover the abundant presence of other galaxies that will enhance our knowledge of space and technology. If you like our content, don't forget to hit the like button and subscribe, and turn on the notification bell to be notified whenever we have a new upload. We will keep you updated on reliable technology news, the latest gadgets, and anything related to the tech world here on Futureland. Thank you for watching and see you on our next video.